Hello, welcome to this lesson. Today we are going to look at the introduction to surd and then simplification to surd. So let's get started. The exact square root of certain numbers can be found readily. So numbers such as root of 4, taking the positive square root, we have 2. Root of 9, we have 3. Root of 1 is 1, and so on. Okay? Now, these numbers are called rational numbers. However, there are some numbers such as root of 2, root of 3, root of 6, and so on, whose exact square root can not be found, but their root can only be found to some degree of accuracy. So taking the positive square root with the help of our calculator or table, we have root of 2 be equal to 1.144142 and so on. They are non-terminating, they are non-recurring. Okay, so root of 3 you get 1.7321 and so on. Okay, then root of 6 you get 2.44 then 94. Okay, I'm just leaving them in 4 decimal places. Okay, so now these numbers are also called irrational numbers. Okay, so irrational numbers. Now, when such numbers are left under the square root, they are called surd. Okay, so we can just give an example of surd. For example, we have root of 7, we have root of 11, we have root of 13, we have root of 24, we have root of 32, we have root of 27, and so on. Okay, so these numbers are called surd. So when you talk of surd, we are talking of when non-perfect square numbers are left under the square, there's root sign. Now, surd may also take the form of the third root of 7, the fourth root of 11, and so on. Okay, now remember, if you have the third root of 7, this is not equal to 3 multiplied by 7. So in this case, this is the third root of 7, and this is also 3 multiplying root of 7, square root of 7. Okay, now if you also have the fourth root of 11, it is not equal to 11 multiplying by the square root 4 multiplying by the square root of 11. Okay, so take note of this. Now, so considering the first 3 examples of our surd, we're going to look at something very important. Okay, so considering the first 3 examples, we realize that it is not possible to express the number 7, the number 11, and the number 13 as a product of 2 factors, where one is a perfect square and the other is not a perfect square, except 1. So these numbers or this surd cannot be reduced further. Then they are said to be in their basic form. Are you okay? So you can think of another example like root of 2. There's no way you can express the number 2 as a product of 2 factors, where one is a perfect square other than 1 and the other one is not. So this root of 2 is a surd, but it's in the basic form. Are you okay? Good. Now, if you also look at the last 3 examples of the surd on the board as root of 24, root of 32 and root of 27. Okay, you can express, it's possible to express the number of 24, 32, then 27 as a product of two factors, where one is a perfect square and the other one is not. Let's look at this. So if you take the root of 24, okay, you can express 24, get a perfect square and then not a perfect square. So you can say 4 is a perfect square multiplies by 6, which is not a perfect square. Now this 6 is in list form, meaning that there's no any other perfect square except 1 that you can express 6. So 4 times 6 will give us 24. So now you can reduce this into its basic form. So we have when you get something like this, we just split them out. So we have root of 4 multiplies by root of 6. Now we already know root of 4 is 2, that's the positive square root, multiplied by root of 6. So in this case, this is the basic form of root 24. Are you okay? So let's also look at the root of 32. So now you have 32 can be expressed as two factors, where one is a perfect square and the other one is not. So we have 16 multiplied by 2. Okay, so 16 is a perfect square, 2 is not a perfect square, but 2 is also in its list form. Okay, so we can spread them out. Root of 16 multiplies by root of 2. So in this case, the positive square root of 16 will give us 4 multiplied by root of 2. So the basic form of root of 32 is 4 root 2. Are you okay? Okay, so let's solve some few examples on the reduction of surd to the basic form. Okay, I'm not going to claim this because we're going to look at something important. Okay, so we have 1 root of 150. Okay, root of 150. Now in this case, finding two factors of 150, of which one is a perfect square and which one is not, we have 25 multiplies by 6. See, 25 times 6 is 150. Okay, so here we go. Root of 25 multiplies by root of 6. Now taking the positive square root of 25, we have 5, then multiplies by root of 6. So that is it. Another example, root of 128. Now 128 can be expressed as two factors, where one is a perfect square. So we have 64 multiplies by 2 will give us 128. Okay, so in this case we split them. 64 multiplied by root of 2. Okay, so here we go. Now taking the positive square root of 64, we have 8. So we have 8 multiplied by root of 2. So 8 root 2 is the least form or the basic form of root 128. Okay, now if you look at this, you learn something very important, and then we have to take note. Reducing surd to its basic form, look at this, we have 8. So if you square it, you get 64. We have 5, you square it, you get 25. Okay, we have 2, if you square, you get 4. We have 4, if you square, you get 16. And the 16 multiplied by the number under the root give us the two factors. So in case of large numbers, that is difficult to find the two factors. For example, if you have root of 6, 4, 9, 8. Okay, now find the two factors here may be extremely difficult. In this case, the calculator is there to help you out, though the question may demand without using calculator or table, but yet you can also use the calculator to find out the two factors which one is what? Perfect square, and another is none. What you do is that first you punch root of 6, 4, 9, 8 on the calculator. So the calculator will give you, and let's display on the screen. The calculator will just give you 57 root 2 as displayed on the screen. Now, when you get something like this, just square the 57 outside and multiply by the number under the root sign, and you get the two factors. Okay, so 57 root 2, 57 squared will give us 3249 multiplied by 2. Okay, if you have difficulties in finding square numbers, you can check out from my videos. I've made a video tutorial on that. Okay, so here we go. So we have root of 3249 multiplied by root of 2, and you already know that root of this is 57. So 57 root 2. Okay, it is very simple. So in this case, it will seem like you have not used the calculator, but anyway, it helped you to find the factors to simplify your set. Are you okay? Good. So let's take another example. We have simplify 4805, and if it is difficult to find the two factors, just point this on the calculator as displayed on the screen. Okay, you will realize that the calculator will give you 31 with 5. Okay, so 31, just square the 31. Always square the number outside the root, then multiply by the number with the inside the root. So 31 squared will give you 961 multiplied by 5. Are you okay? So here we go. You spread them out. 961 multiplied by root of 5. So know the root of 961 will give us 31, then multiplied by root of 5. So we have 31 root 5. Okay, so in general, the calculator can help you, or can help us, to reduce large sets to their simplest form. Okay, now I hope it's clear. Thank you for watching. I want you guys to subscribe, then comment on my video.